Hello, good morning, good afternoon, good evening, depends on where you are watching from. I'm Gostan. You can call me Goddess on Tricks. Okay, today I'll be explaining one of the first phenomena approach or concept of physics. Like I've already explained physics to you. Physics help you to understand the universe and its application. One of them we'll be looking at is thermodynamics. Yes, because everywhere there's heat, there's heat, there's heat. When sun hits on you, when you cook, is heat. So majorly, I'll be talking about heat equilibrumity of a thermodynamic. Now, in the first law of thermodynamics, aside zeroth law, zeroth law, in the first law, although the same thing, they are almost talking the same thing. The first law told you that it can never be created nor destroyed, but can be transformed from one form or another. And chemistry back the same law. Okay. To me, that concept, I coined the word for it. Heat equilibrumity of thermodynamics, and I think other physicists should welcome the idea. Don't mind me. So let's continue. Now, students normally have problem with the equational approach. Change in U is equals to change in Q minus change in W. That is physics approach. I think in chemistry they'll tell that change in U is equals to change in Q plus change in W. Okay, either case, I will explain it to you today. Now, the process of heat transfer are three majorly: convection, conduction, and radiation. Okay, I will be mostly concerned with conduction because there's an approach to convection in conduction because conduction is two types. We have thermal conduction and electrical conduction. So these are the two major things. That's why you are seeing change in U is equals to change in Q minus change in W. I believe physicists will accept this approach because I haven't seen it being spelled out this way in any textbooks per se from the one I've read so far. So I think it's my approach to this space that I'm bringing out this founding. Thank you. Okay. Now, changing U is the internal energy. Okay, let me use relating thermal conductivity and electrical conductivity. When you on your source of heat, like your socket, and you applied your utensil, and there is either you add liquid or you add a solid like rice or your water. When heat is transferred, when your socket is hot, heat is actually transferred. That is changing U. Are you getting me? Now, what happens is that the system absorbs this heat. When the system absorbs it, we say the system performed a work. So work is done by the system. At that point, the work actually is positive. Are you getting me? Then the heat, because the heat was transferred or supplied, we then say the heat is also positive. Then changing U is actually going to be changing Q minus changing W at this point. But now let's look at it this way. Like you all know, when you are heating up water or you are cooking your rice, at the time the rice get done, when I say work done, work is done. So what now happen? You put off your power supply, your source of heat. When you put it off, what happened? The same system now that work was done by when it was supplied is now going to release the same heat. Here, are you getting my point? So you now see that there's now heat loss, and this heat is being lost to the environment. The same way the heat was supplied, transferred, the heat was gained from the environment into the system, and work was able to be done by the system. When I say that work that was done by the system is positive, then the heat that was transferred again is positive. But at this point, since work has been done by the system, now the system is losing it. It's losing the same amount of heat, equilibrumity, that was transferred in. We now said in that case, change in Q is negative. So whenever heat is lost to the environment again, not transferred into the system, we say that heat is negative. But when it is transferred, it is gained from the environment to the system, we say that heat is positive. I don't know if you are getting it now. Now, when the heat is transferred, work is done by the system. We then say that work is what? Positive. Are you getting me? Because it gains the heat that was transferred in. But now, when the work has been done, the system again is losing out. At that point, you said work is now done on the system. Why? Because the system is actually doing another kind of work by losing an energy to the what? Environment. So work done on the system is now going to be negative. So when you are given a question and they say work done is on the system, know that at that point there's going to be negative W. So change in U is equals to change in Q minus bracket minus negative W. Now mathematically the minus will cancel themselves, it become plus. That is the approach chemistry used. I don't know if you are getting me. So students often having problem with sign convention in it. I think it's as a result of not having proper understanding. And I believe with this video, you have gotten a clear understanding. See you at the comment section. Thank you.